Okay, this is Algebra 2, and we're looking at characteristics of relations and functions, Part 2. We're going to start by looking and matching the verbal description to the graph that it describes. If you're talking about the intersection of x equals 0 and y equals 0, this is where your axes intersect. It's known as your origin, and so it would be this picture here. A set of ordered pairs represented by a set of points, graph, or an equation. There's really a lot of these that would fit. As long as it's a set of ordered pairs, or you can plot points, it is a relation. So this would be a sample here. Both the x values and the y values increase. If they're both going up, it is going to be an increasing graph, so it should go up to the right. If the x values increase and the y values decrease, your graph is going to go down to the right. Intervals in the graph where the function goes up from left to right are your increasing. Okay, so it would still be this. Points that are not connected would be something such as this. An infinite number of points would have to be something that was a solid line. Points that are not connected, we've already talked about. An infinite number of points, we've already talked about. The independent variable, this is your x. So you're looking for a word or a letter. Individual points are just all the different points on your graph. It could be any of these. A relation in which each element of the domain is paired with exactly one element of the range is a function. Lots of these would work. This one passes your vertical line test though, so it is one. Your y coordinate is going to be the y value of each point. Intersection of the x and the y axes are going to be the origin. X coordinates, the first number in a point. Dependent variable is the y. It is the word, the letter actually, of what you're finding. Points are written as x comma y. 0, 0 is your origin. If the vertical line only crosses the graph once, it passes the vertical line test and it is a function. Intervals in the graph when the function goes down from left to right would be called decreasing. Set of points in which the x value only occurs once would be a function. And a line or a smooth curve would be continuous data. So looking at this is just kind of a continuation where we were looking at stuff last week. Is this data discrete or continuous? It is continuous because you have a solid line going on. The domain is going to be -5 is less than or equal to x is less than or equal to 3. You got your -5 from the point furthest to the left and your 3 from the point furthest to the right. And I do have a mistake. It should not be less than or equal to 3. It's just less than. The reason for that is that this is an open circle here at the end. Your range goes from bottom to top, so it would be -2 is less than y is less than or equal to 4. This was my low number. This was my high number. Low number was an open circle, so I did not put equal to. High number was a closed circle, so I did. Is it a function? Yes, it is a function because it passes the vertical line test. Intervals where it is increasing. It increases when it goes up from left to right. When you describe an interval, you only use the x value, okay? So -2 is less than x is less than 1. I took the x value here and the x value here. When you're describing an interval that it's increasing or decreasing, you will never have the or equal to. You will never put that line because at -2 and at 1, it's like a starting point and a stopping point. It's not actually increasing right there. Interval where it's decreasing, there are actually 2. Here's one and here is another. So using your x values, -5 is less than x is less than -2. And then 1 is less than x is less than 3. Pulled my x values for both of them. You're going to have to do this on the assignment. Make sure you got that. Okay, so now looking at your notes handout. Function notation. Function notation is a method used to represent the point as part of a function. It does not have to be f of x. It could be any letter. If you have f of x is equal to 2x plus 3, and they want you to find f of 4 and to find negative 1, they want you to put this number in for x and solve, and then do it again with this number. So you're going to have two answers. So you would say f of 4 means 2 times 4 plus 3. And then you would say over here, f of negative 1 is equal to 2 times negative 1 plus 3. And you would put this in your calculator and you would get 11. So your ordered pair is 4, 11. The number you put in, comma, the number you got. When you put negative 1 in, you get negative 1. So your ordered pair is negative 1, negative 1. No, it's a positive 1. This should not be a negative there. So looking at A, given the function x squared, g of x is equal to x squared plus 2 and h of x is equal to 4x plus 10, evaluate the following. What you've got to be careful about when they've done something like this is you've got to make sure and put the number into the right problem. This is h, and so 3 is going to go way over here. And you're going to say 4 times 3 plus 10. And you're going to get 22. This next one is g of negative 3. So negative 3 is going to go to the first equation, or the first function. Negative 3 is going to go over here. Now you got to be careful, because that negative 3 needs to go in parentheses before you square it. And then you say plus 2. And when you do that, you should get 11. Now when you have g of a plus 1, it works a little different, because you're having to put a letter in. Okay, so you can't just go to your calculator. Give myself some room there. So what you're going to say, you're using the g function. So it's x squared plus 2. X is now a plus 1. So it's a plus 1 squared plus 2. Well, a plus 1 squared means a plus 1 times a plus 1. And then we bring down your plus 2. So you've got to distribute your a times a plus 1. So that's going to give you a squared plus a. Because a times a is a squared, a times 1 is just a. Then you distribute your 1 to the a plus 1. So plus a plus 1. And then don't lose your plus 2 at the end. So now you got to combine like terms. So you have a squared, and then a plus a combines and gives you plus 2a. And then 1 plus 2 combines and gives you plus 3. And this is your answer. Okay, that's one of the longer ones for today. You kind of have to stop and think about what you're doing. In function notation, x comma f of x, which symbol represents the domain and the range? X is always your domain. F of x took the place of y, and so it is your range. Okay? Domain is x, range is f of x, because y and f of x are the same thing. What are the benefits of using function notation? The reason you want to do this is to distinguish functions, okay? So that you can distinguish functions by letter. If you have more than one thing going on, you pick a letter that has something to do with what it's talking about. All right, number 4, label the axes, the origin, and the quadrants of the coordinate plane below, and then graph the points in the set. So what you should do is fix your graph so that it looks something like this. So take a minute, label things, plot your points. Identify the domain. We know that domain is talking about x. So you can just go back up. Even though you've made a graph, you can just look at your set of points that they gave you. And remember that the x values are your domain. So it's going to be -3, -2, 0, 1, 3, and 4. Remember, I do not care what order you give these numbers in, and I don't care if you repeat when they show up more than once. Identify the range. Once again, go back and just look at your set of points, and the range will be all of the y values. So -5, -2, 0, 4, and 5. Is the relation a function? Remember, x can't repeat. So go back up here and look. -2, 3, -3, 0, 1, 4, and 0. We have 0 and 0 again. So that would be a repeat, and it is not a function. Is it continuous or discrete? Okay, I talked to several of you last week about this. Continuous is if they give you an equation or if they give you a solid line on the graph. Anything else basically is discrete. You've got to go and see, well, what did they give me at the beginning? Did they give you this graph? No. The first thing they gave you was a set of points. Is that an equation? No, it's not. Is that a solid line? No, it's not even a graph. It's a set of points. If it's not an equation and it's not a solid line, it's going to be discrete. Which means when you look at your graph, you don't draw a line connecting your dots. Going to the next page. All right, so they've given us a graph, and they want to know, first of all, what is the domain? Well, remember, domain is going to be going from left to right. So we start at -2. We do not put a line because that is an open circle. Remember, open circle is less than, and a closed circle is less than or equal to. It's domain, so x has to go in the middle. We end with the closed circle, so less than or equal to, and then count over. 1, 2, 3, 4. So -2 is less than x is less than or equal to 4 is your domain. Range works the same way, except you're going from bottom to top. So you see how low it went, and you see how high it went. 1, 2, 3, 4. So it got as low as -4. It's a solid circle, so you put a line. Range talks about y. Your top circle was solid, so it gets a line, and count up. 1, 2, 3. So -4 is less than or equal to y is less than or equal to 3. Is it a function? Come back up here and do your vertical line test. Anywhere I cross that, it's only going to touch it once. So yes, this is a function. Is it continuous or discrete? Well, the first thing they gave me was a graph. So then you got to say, well, does that graph have dots or does that graph have a solid line? It's a solid line, and that makes it continuous. And then on what intervals is it increasing and what intervals is it decreasing? So you're increasing here and you're increasing here. Remember, you only use the x value to describe this, and you never put an equal to sign with it. So we're going to go from -2 to 0, and then from 2 to 4. So you have two different increasing intervals. -2 is less than x is less than 0, and then 2 is less than x is less than 4. When you look at decreasing, you only have one interval, and it's right here, going from 0 to 2. You only use the x values to describe your interval. So 0 is less than x is less than 2. Looking at the next graph, they want the domain. It's different here because you have an arrow there. So it starts at 0, but it goes forever to the right. That means 0 is less than or equal to x, but you don't put a stopping point because it goes on and on. Your range, same thing. As low as it gets is 0 is less than or equal to y, but it can go up forever, so you don't put a stopping point. Is it a function? Yes, it is a function. It passes my vertical line test. Is it continuous or discrete? They gave me a graph with a solid line, and so that makes it continuous. On what interval is it increasing? Well, it starts going up at 0 is less than x, because we never put that line. When does it quit going up? It doesn't. It goes up forever, so you don't put a stopping point. And then on what interval is it decreasing? Where at on this graph is it going down? It never is, and so you can tell me there's not one, you can tell me NA, you can tell me none. Okay, on the next page, they want you to start by completing the table of values. What you would do is you would put this into your calculator, 2 times the absolute value of x minus 1. So you go to y equal, you clear everything out, and you say 2, math, go over to num. Number 1 is absolute value. We ought to be at y equal for this. 2, math, num. Number 1 for absolute value, x minus 1. Then go second graph and pull up your table. And you want your table, second table set up to start at 0. Go back to your table, and you would use these points, going up and having it start at -3, to fill in the graph. I'm going to stop this and start a second video.